Trends. So a trend is a predictable change in a particular direction. Understanding a trend among the elements enables you to make predictions about the chemical behavior of elements. These trends and properties of the elements in a group or period can be explained in terms of electron configuration. So the first trend, atomic radius, lets us know the size of the atom, and it measures using half the distance between the nuclei of identical atoms bonded together. So the trend on the periodic table, as we increase the atomic number or go down a group, each atom has another energy level, so the atoms get bigger. So as we go down, our atomic radius is going to increase. So from going from left to right, across a period, the size gets smaller. Electrons are in the same energy level, but there's more nuclear charge. So there's more protons. So more charge pulls electrons in closer. And remember, opposites attract. So as we go from left to right, we decrease. Now, ionic radius tells us the size of the ion. And we know an ion is a positive or negative atom because of a loss or gain of an electron. Positive ions are called cations. Negative ions are called anions. So valence electrons, the electrons available to be lost, gained, or shared in the formation of chemical compounds, are referred to as valence electrons. Valence electrons correspond with the group number of an element. So for example, carbon is in group 4A, so carbon will have 4 valence electrons. So group 1A has 1, 2A, 2, 3A, 3, 4A, 4, 5A, 5, 6A, 6, 7A, 7, and then 8A will have 8. Group 8 will have 8 valence electrons. Okay, so cations are smaller than their parent, right? Cations lose electrons. So if we had Na and Na plus 1, and the question said which one is bigger, okay, it would be Na, the stable atom. Now, anions are larger than their parent. They gain electrons. So if the question asks which would be bigger, Cl or Cl minus 1, it'll be Cl minus 1 because anions are larger than their parent. So as you move across a period, the ionic radii of metal cations tend to decrease because of the increasing nuclear charge. As you proceed through the anions on the right of the period, ionic radii still tend to decrease because of the anions' increasing nuclear charge. Now, I'm going to do a quick example of a proton, neutron, electron an electron configuration for an ion. So say I wanted to do the electron configuration for F minus 1. So in my stable neutral atom, if it was just F, I would have 9 electrons. But since I have this minus 1, I'm actually going to add 1 electron. So I'm going to have 10 electrons in my electron configuration. So it'll be 1s2, 2s2, 2p6. Now, if I had one Al plus 3, so aluminum, my stable neutral atom, will be 13 electrons. But this plus 3 actually means minus 3 electrons. So I'm going to have 10 electrons. So it would be 1s2, 2s2, 2p6. Now, ionization energy, the amount of energy required to remove an electron from an atom. Example, removing one electron makes a +1 ion. Going down a group, the ionization energy decreases. Because the electron is further away from the attraction of the positive nucleus. A lower ionization energy means it takes less energy. It's easier to remove the electron. So all the atoms in the same period, left to right, have the same energy level, but increasing nuclear charge, so there's more protons. So when we go from left to right, the ionization energy increases. So ionization energy increase as you go left to right, and then decrease as you go up to down. Okay, opposite of ionization energy is electron affinity. Energy change when an electron is added to an atom. Energy release means that it's easier to add electrons, even though they're opposites, they have the same trend. So you decrease as you go across, you increase as you go across, and you decrease as you go down. Electronegativity. Measure the ability of an atom to attract electrons when it is bonded to another atom. Think sharing with a partner, equal sharing, or unequal sharing. Fluorine is the most electronegative element. The farther down a group, the farther the electron is away from the nucleus, plus the more electrons an atom has, thus more willing to share. Which means lower electronegativity. Okay, so metals are at the left of the table. They form positive charges. They let their electrons go easily. Thus, they have a lower electronegativity. At the right end are the nonmetals. They form negative charges. They want more electrons. They try to take them away from others. They have a higher electronegativity. So a melting point and boiling point trend. As you move down the periodic table, you have an increase you have a positive, right? So boiling point and melting point decreases. And when you have a negative, your boiling point and melting point increases. Okay, so metals have the highest melting point and nonmetals have the lowest melting point. And this last chart, graph just shows, or image, shows us all our trends in one location. And this concludes our video on periodic trends.